So, good evening to all of you. Good evening to all of you. Audible and visible properly, beta. Audible and visible properly. Any issue? कुछ बच्चे बता रहे नॉट ऑडिबल, दो बच्चों का बताया ऑडिबल 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 Yes, I am fine, beta. Students are asking, I find every day few messages will be there. So, today that we will start with the nuclear technology. Very interesting topic it is. And okay, I'll see into it, Subham. So, nuclear technology that we are going to see, and so many things under it we'll have to see. First, I am going for the flow chart for the nuclear technology. First, we will see the nuclear concept. In this one, we'll have to see nuclear energy, and under the nuclear energy, there is a nuclear fission, nuclear fusion, thereafter nuclear fuel cycle, then we'll have to see components of nuclear reactor, and nuclear reactor means we can say like the power plant which are producing electricity, with the help of nuclear energy. That is known as nuclear reactor. So, there is a components of nuclear reactor. We will have to see types of nuclear reactor. Thereafter, we will see the three-stage program of India's nuclear reactor. Three-stage program of India's nuclear reactor. So, under the nuclear technology concept, under the heading of this, we will have to see the first, it is nuclear energy, then we will see the nuclear fuel cycle, another it is components of nuclear reactor, types of nuclear reactor, the important types, and what is the three-stage nuclear program of India's nuclear reactor that the Homi Jahangir Bhabha has prepared, that India doesn't have too much of uranium. So, on the basis of that, what should be the stage for developing nuclear power, nuclear energy in India? So, that is in a very fine stage that has been. When you will study that, you will must salute Mr. Bhabha, who has been died in 1966. So, here it is under the nuclear technology concept, these are the topics we will have to see. Thereafter, we will have to see, like I said, that international nuclear organization, nuclear related organization, or better to say the diplomatic organizations which help in the different relations. We will have to see IAEA, International Atomic Energy Agency, IAEA. Thereafter, we will see NPT, Non-Proliferation Treaty, that is 1970, 1957 IAEA. Then we will have to see like Pokhran issue, because it is important. Pokhran, I said Pokhran 1 issue 1974, thereafter NSG, Nuclear Supplier Group 1975, thereafter there is Australian group. Just after 8 years break. So, here it is 1957 around International Atomic Energy Agency, NPT Non-Proliferation Treaty 1970, Pokhran 1, first we have done our nuclear test 1974, it is also known as Smiling Buddha. It is also known as smiling Buddha. Australian group, and thereafter NSG nuclear supplier group. Just due to the Pokhran one done by India, in the world community has shattered, and they have formed another group. Its name is Nuclear Supplier Group 1975. And after 10 years of nuclear supplier group, there is a 1985, there is an Australian group came. Clear? So just 2 years after Australian group, you can remember like that AMW. After A letter, which letter comes? M. M means Missile Technology Control Regime, and W means Wassenaar Arrangement. So Australian group 1985, just 2 years after Australian group, there is a missile MTCR, that is missile technology control regime, that is 1987. AM 1985 Australian group, and MTCR missile technology control regime 1987. After that, in 1996 there is Wassenaar Arrangement. Sometimes it is written like agreement also, but it is Wassenaar Arrangement. You remember that there is 2 letters in the S and 2 letters in the A. 2 letters of A, 2 letters of S. I'll use these 2 letters words to understand the concept of Wassenaar Arrangement. 1996, 1975 Australian group, 1985 Australian group, 1987 we have missile technology control regime, and 1996 we have Wassenaar Arrangement, and the same 1996 there is a CTBT, and it is Comprehensive Test Ban Treaty. Comprehensive Test Ban Treaty. Then in 1998, in the month of May, India has done the second test. Pokhran 2 issue we have to see. And thereafter India has been sanctioned at several places in the several aspects, in the trade, in the supply of machines, in the supply of, I said that any kind of loans, that the grants, that the any I said humanitarian aid any country is giving to the India. At several points that it is, I said India was sanctioned for few years, but after that again the India revamp and come back, and around you can say that 2005 to 2000, better to say 8, during that period Indo-US nuclear deal, Indo-US nuclear deal, that is also known as 1-2-3 nuclear deal, or you can also say one point about it, it is an NSG waiver, NSG nuclear supplier group waiver. So India has got something, he is not able to become the member of it, but he is getting NSG waiver. So the 2005, 2008 and then 2010 we have to see, it's not the part of diplomacy, but it is part, there is a Nuclear Liability Act we have to see. Nuclear Liability Act. So let me revise it once. I said that first one I said International Atomic Energy Agency 1957, and in 1970 we have got there is a non-proliferation treaty. It came into force. Otherwise it has been established in 1968, but it has come into force in 1970. After the coming into force 4 years after, India has done a Pokhran test, Pokhran 1. And then there is, I said that after Pokhran test, the world community said that India is one of the growing nuclear power and it is not good for the world. They have said just next year 1975, it is nuclear supplier group. So here it is, we have been able to see nuclear supplier group. And then 1985, there is a coming of Australian group. So nuclear supply, that is for the nuclear supply related, that much I can say right now. That is related to, it is also a multilateral control export, multilateral export control regime, nuclear supplier group. Then 1985, another multilateral export control regime, it is, I said that Australian group. Missile technology control regime, it is also multilateral export control regime, 1987. Wassenaar arrangement 1996, it is also multilateral, I said that export control regime in 1996. These are the 4 organization which is for the multilateral export control regime. Means I said that it is for the controlling the export of particular, I said that technology or maybe an arsenal, maybe in a goods, maybe in a chemicals, whatever it is there, it is related to missile and all. So 1996, there is the world community thought of bringing of CTBT, Comprehensive Test Ban Treaty in, but till now this CTBT is not looking. I said that India is not a member of NPT. India did not sign the CTBT also, Non-Proliferation Treaty of 1970, and I said that CTBT also. So he has an issue, something that we will discuss. I will discuss each and everything in the detail so that you can be able to correlate all these things, topics here and there, current affair. And at times you can utilize in the missile space technology also, you can utilize in the I said defense also, because the nuclear can be the one of the important part for the energy. And Pokhran 2, that issue, India has again shown his power that I have a nuclear bomb. And this is the time India has in the Pokhran 2, in the Pokhran 1, India has shown about that they have an atomic bomb. And in the Pokhran 2, India has shown that India has a hydrogen bomb as well as atomic bomb. So this is the, I said that. And this is the there is a difference that will say that what is the difference between Pokhran 1 and Pokhran 2 and all. And thereafter there is lots of sanction 1998. You know that the just next year 1999, India and Pakistan Kargil war has been taken place. 2005 that it is George Bush was the president of United States. And I'll say that whosoever the president of United States till now, and as far as the nuclear is concerned, he is the one of the greatest president who has given favor for India to become the part of nuclear supplier group. He has changed in his some constitutional act as far as the nuclear power is concerned. And India has been involved in the nuclear deal. It is George Bush. Whatever you have heard the name Bill Clinton, you have heard the name of so many other Barack Obama and so many other names perhaps you remember. But I'll suggest that George Bush, who is, I said that great president who has supported India at the time when it is required. And 2010 this is Indo-US nuclear deal. If you have heard about it, is also known as 1, 2, 3 nuclear deal. And this is in this during this Indo-US nuclear deal, India has got the NSG waiver, means he is not the member of NSG, and but even then he is able to get some kind of waiver. 2010 Nuclear Liability Act, that it is there. So these are the things that we have to see at the international diplomatic level, international diplomacy or organizations. And the next one we have to see that it is some organization at the level of India. I said Indian organization related to nuclear energy, and there is, I said that Indian Atomic Energy Commission, IAEC, 1948. Thereafter there is a coming of, I said that Department of Atomic Energy, and it is the what apex body. You can say that apex body for all in 1954, Department of Atomic Energy. And another thing that we have to see, like then we'll have to see BARK, Bhabha Atomic Research Center. In the 1967, after the death of Homi Jahangir Bhabha, he has been died in 1966. Earlier its name was Atomic Energy Establishment Trombay. Its name was, earlier name was Atomic Energy Establishment Trombay, AEET. So this AET converted into BARK. This AET, it was also established in 1954, but it became BARK in 1967 after the death of Homi Jahangir Bhabha. Only the name has been changed. Another point that we'll have to see, like BARK, then there is a variable energy cyclotron center. Variable energy cyclotron center means, I said that it is important for hydrogen bomb or it is international thermonuclear reactor. It is means, I said that nuclear fusion, especially it is nuclear fusion related important technology, where we have to make the movement of electron at a very, I said that particles to move at very fast speed and producing energy over there. So that is variable energy cyclotron center, that I can say VEC, that is at Kolkata. So Indian Atomic Energy Commission, then Department Indian Atomic Energy Commission 1948, Department of Atomic Energy 1954, BARK, earlier its name was Atomic Energy Establishment Trombay, it has been converted into Bhabha Atomic Research Center. Next one, it is Variable Energy Cyclotron Center. Thereafter we have to see Indira Gandhi Center for Indira Gandhi Center for Atomic Research. This is at it is in the Tamil Nadu, near, I said that Chennai, south of Chennai, there is a region Kalapakkam. There is a Kalapakkam. There is a Kalapakkam. South of Chennai. There it is, and this is the reason where India's second stage nuclear program, that is, you can say that fast breeder reactor, all the things, all the names, it will become very much clear after 3-4 days. You will start becoming highly comfortable, and at the end of this class you will find that that's a very easy topic. Indira Gandhi Center for Atomic Research, and even if you have a science background or not, doesn't matter. Simple, you should be studious, you should be, I said that, ready to learn a lot. Indira Gandhi Center for Atomic Research, Kalapakkam, and after that another very famous portion of Pokhran 1. Pokhran 1, very famous portion, he is also known as a father of atomic bomb, and 1954 the first time we have done that experiment. And then on the basis of his name, there is one organization is there, Raja Ramanna Center for Advanced Research, Center for Advanced. If I am talking about this Raja Ramanna, in 1974, there is a Vikram Sarabhai, there is a, I said that Senthana, there are several portions are there, but the Raja Ramanna was the head of it, and then Pokhran 1 test has been done on the name of his, there is an, I said, he is considered as an, I said that father of atomic bomb, but certain books does not say Raja Ramanna. And Raja Ramanna, if I am talking about this Center for Advanced Research, it is not for atomic, but it is for the laser. You know that China has got this laser technology, recently it was in the news, and then India is doing working on the particle accelerator and laser war and all. So it is in an institute, it is where we are working on the lasers and particle accelerator, means it is different from nuclear, but it is one of the assistant of nuclear energy itself. So Raja Ramanna Center for Advanced Research. Another, Atomic Mineral Department for Exploration and Research. Atomic Mineral Department for Exploration and Research, AMDER. Clear? This is Indira Gandhi Center, it is IGCAR, it is Raja Ramanna, it is RRCAR. So very much important, you can easily remember Indira Gandhi Center, Raja Ramanna Center, it is the same kind of the name. One is for atomic research, another is for advanced research. Indira Gandhi Center for Atomic Research, Raja Ramanna Center for Advanced Research. And Atomic Minerals Department means exploring and finding out different nuclear fuels in the India and their exploration and the research. It is this is the one thing. And variable energy cyclotron, Indian Atomic Energy Commission, and the Department of Atomic Energy 1954, then the BARC, Variable Energy Cyclotron Center. Try to remember the name. You should try to, if you remember the facts, then it will be very easy to associate your concept with the facts, and it will remain for a long time, and it will take very small time for you to revise it. And whenever something coming into the current affairs, you can be able to relate it. Generally the problem and the panga with the student is that they have, I said that when they have studied, suppose economy, polity, geography, whatever it is they are reading, they are not able to, they are not correlating and not able to correlate with the, I said that, current affairs. So I just always say that whenever you are reading this one, you should be highly capable to understand that and then it is of one editorial of any kind of, I said that news related to science and tech, or whatever the topic that I am teaching, you should be comfortable in understanding, and you can make your own notes on that. So, it is very much important to remember the name, and there slowly and slowly, if you have seen that I used to make all of you remember the concept. I am trying to give you the concept, but at the same time making you to remember the facts the way that I try to teach you. So, clear? So, variable, these are the, so Indian Atomic Energy Commission, Department of Atomic Energy, there is BARC, Variable Energy Cyclotron Center, and there it is Indira Gandhi Center for Atomic Research, Raja Ramanna Center for Advanced Research, and then Atomic Mineral Department for Exploration and Research. These are the important, we will have to see the Indian, I said that nuclear related organizations. So, here we have to see like this, and then if we have to see like another type, another point that we have to see some issues like Jadpur atomic power plant or reactor. It is in Maharashtra, Ratnagiri district, Jadpur, and one it is, I said that Kundakulam atomic power plant issue. Okay. And when I will teach you at the same time, there are several other miscellaneous topics, something will be there that will be also included. And I said that uranium in India, thorium in India, and in the world their context. So, that concept that also I will give you, so that you can be able to correlate. So, I will make you to remember the distribution of uranium in India also, in the world also. So, here it is, these are the things that we have to see in the next coming days, and some miscellaneous will be also there, some miscellaneous. So, we have to see nuclear concept, nuclear energy. So, this is one of the biggest topic, it is, I said that, and I will keep on correlating one topic with the other topic to make you to understand. There is I said that nuclear fuel cycle, components of nuclear reactor, types of nuclear reactor, 3-stage program of India's nuclear reactor. It is one of the greatest, I said that stage program, and I am very happy with that the India is having such kind of a stage. Means whatever we have, on the basis of that we should try to develop that kind of it. So, earlier Homi Jahangir Bhabha, you know that in the 1944 and 1940, that Homi Jahangir Bhabha started saying that India should have nuclear power, nuclear energy to produce electricity and also power. And thereafter in 1945, you know that the first time in Hiroshima and Nagasaki, there is a nuclear atomic bomb has been in the name of little boy and fat man has been, I said that, exploded in Japan. So, I said that before that our Homi Jahangir Bhabha was talking about. So, somewhere Homi Jahangir Bhabha can have a nuclear power, making in India to be a nuclear powerful country. So, there is some diplomacy and something like this. It is there which make India not to be getting nuclear power. He can get earlier nuclear power, and Homi Jahangir Bhabha, most of our scientists has been, nuclear scientists has been, I said that, killed. And Homi Jahangir Bhabha still we do not know that what are the reason that there is an aeroplane failure taken place, and he has been in the accident, he has been died. So, and thereafter we will see some diplomatic international organizations, and this is IAEA, NPT, Pokhran 1, Nuclear Supplier Group, Australian Group, Missile Technology Control Regime, and then we will have to see Wassenaar Arrangement, Comprehensive Test Ban Treaty, Pokhran 2 issue, 2005 and 8, India-US Nuclear Deal, and 2010 Nuclear Liability Act, and thereafter Indian organizations will have to see, and some issues, and it can have some, I said that miscellaneous. So, you got to know that what to study. So, now we are going to start with the, I said the nuclear energy. Nuclear energy, if you know that there are the two types of nuclear energy. One, it is you have studied in the class 9th and 10th, and also if you have a science in, then you have studied in the class 11th, 12th. The nuclear energy, and very simple, it is not, I am going to talk about it, is a hard concept. If you know that it is a nuclear fission, one, it is nuclear fission, and in the fusion means only it is, I said that breaking concept you should remember, nuclear fission. Another, it is, I said that nuclear fusion means here it is a nuclear are combining, here the nuclear is, I said that breaking, nuclear fission, and ultimately there is a release of energy. Our job is only what, release of energy, release ho gaya, that is the purpose, and here it is also ultimately release of energy, release of energy. So this is the nuclear fusion and nuclear fission, here it is. Now I said that here the more important is what, combination, combined, and here it is breaking. So what happened, there should be, I said that unstable nuclear, there is a large, here it is, what is I said that nuclear radioactive material. If I said that radioactive mineral, and who is radioactive mineral means that the nucleus should be unstable, nucleus should be unstable. When the nucleus is unstable, then they can break into a smaller nucleus. When a nucleus is, I said that unstable, then try to become stable, he will, I said that dissociate or break into what I said that smaller nucleus. And another, this nucleus should have what, isotopes, should be isotope. Isotope means, I said that I said that uranium, and all have 92 as an atomic number, all has 92 as an atomic number, but the mass is different. This is known as, I said that should be isotopic. Means I said that it can be in the form of, I said that 233, this uranium, 235 or 238. So these are the three types of uranium isotope. Means I said that radioactive mineral should be what kind of quality, that the nucleus should be unstable to break into smaller nuclei, and it should have an isotopes, that you can see that uranium has this much of the isotopes, and if it is, and they are releasing, I said that sometimes gamma rays, they are releasing gamma rays, they are releasing beta rays, or maybe alpha rays, understood. So they are releasing different kind of, I said that radiations, so they should also, radiation should be there, yes or not. So when they are breaking, during the breaking they should release a high amount of energy, and it is in the form of this one, and this energy is in the form of MeV. These energies are in the form of, MeV, means mega electron volt. So you must remember that mega electron volt. So this is MeV, mega. So when the energy release, sometimes you know that there is a word is joule, heat energy is calorie. So there is I said that here it is in which form energy is released. It is, I said that mega electron volt, that you should remember. Clear? So here it is, and what you have been understood, the radioactive mineral should be, its nucleus, large nucleus should be unstable, and it should break into what I said that smaller nuclei, and that nuclei, that large nuclei that is unstable, they should have some isotopes, and they should radiate. When they are releasing energy, they should radiate the some alpha, beta, gamma. It is not necessary that all three rays will be radiated, maybe two, maybe one radiation is there, it depends upon the amount of energy they have. So this is the one idea I have given, that means if I have to talk about what is radioactive minerals. So radioactive mineral is breaking large unstable nuclei. So there is a large unstable, there is a large unstable nucleus. When bombarded with neutron, then it breaks into smaller nuclei, smaller one, smaller two, clear? But during that, if it has I said that 4 mass, suppose it has a 10 mass, if its mass is 10, suppose I am talking about 10 m, then it will give suppose 5 mass here, broken into 5 mass, and here it is 4 mass. And so what is the ultimate? 10 has been converted into 10 mass has been converted into 5 mass and 4 mass, means total mass kitna ban raha hai, that it is on the other side 9 mass, yes or not? So there is a difference of 1 mass, that is known as mass defect. So what happened, there is a mass defect, and that is of 1 mass. Suppose just I am just making you understand that this loss of mass is very much important. This loss of mass is very much important for releasing energy. And again I said that in the another way, there is a large nuclei and it is bombarded with neutron. It has been broken into, I said that 2 smaller nuclei, and there is, I said that it is suppose 10 mass, and here it is 5 mass and 4 mass, and there is I said that delta m is mass defect, that is equal to 1 mass, and perhaps in the 9th and 10th class one thing must have studied. I said one thing you must have studied, like I said that E equals to mc square. E equals to, E means energy, m means mass defect, and c the velocity of light. So here the mass has been that E equals to, you can also write like delta m c square. Delta means change in the mass. What is the mass defect? And those mass defect will be reflect in the form of energy. Those mass defect will reflect in the form of energy, and we can say, like I said that I am just making it to trying to teach you, like I said that you should never forget. Why? Generally the student doesn't understand that how the energy is produced. So again I said that there is a large mass, it has been, I said that 10 m, and it has been by the neutron bombardment. I said that this large mass has been dissociated into a smaller mass of 2 different nuclei, and I said that here it is 5 mass and here it is 4 mass. Then we can write, I said that some amount of energy, but at the same time there is some neutron is also released. So how do this energy has been released? It is, I said that the mass defect has been converted into energy. So we can make another equation like this. The mass defect has been beta atomic bomb and hydrogen bomb I will teach you later on, you can understand, but I am teaching nuclear fusion is a hydrogen bomb, atomic bomb, and I did not say atomic and hydrogen, I said that atomic bomb, if you have heard something. So perhaps after 2 classes you will be come to know about hydrogen bomb. Right now I am working on, I said that atomic bomb. 2 classes or 3 classes I will discuss about the atomic bomb, that is nuclear fusion. Sorry, hydrogen bomb, that is nuclear fission. Right now I am doing nuclear fission. Clear? So here it is. Again we can write the equation like this. There is a large nuclei A. It has been by the neutron bombardment. By the neutron bombardment, it has been, I said that dissociated into B small nuclei, C small nuclei, and at the same time some neutron and the release of energy, and energy will be in the form of mega electron volt. This is the normal equation, you can say that, and this energy is due to mass defect. So if you are able to write this equation, that is also correct. Means I said that what is the nuclear fission when the neutron is bombarded on, when the neutron is bombarded on a large unstable nuclei, when the neutron is bombarded on large unstable nuclei, then it has been disintegrated into 2 smaller nuclei, and the mass defect resulted into release of large energy and some neutrons. Again very simple definition, I said that you can say that when a neutron is bombarded on a large unstable nuclei, it should be unstable. When a neutron is bombarded on a large unstable nuclei, then nuclei has been disintegrated into 2 smaller nuclei with the mass defect in the form of release of high energy, and some neutrons. This is your, I said that nuclear fission, or it is also known as atom. It is, you can say that will come to know about atomic bomb later on, but I said that nuclear fission, atomic bomb is a nuclear fission itself. So I said that when a neutron is, देखो book kiss नहीं लिखना है, do not write anything book kiss, you left everything which you know. Book kiss should not be written in your, I said that in the examination hall. Whatever your concept you are creating, understanding that you are making, what are the facts you are understanding, fact is the fact, but the concept should be written by you in your form. Some definition you remember since childhood, that is okay, maybe class 9th, maybe 10th, 11th, 12th, that is okay, but you try to make your presence that I understand this. Okay. So nuclear fission, when a neutron is bombarded, or better to say thermal neutron, and you just remember that it is also, you can say the thermal neutron. I will tell you later on what is thermal neutron. When a neutron is bombarded on a large unstable nucleus, then it disintegrated into 2 smaller nuclei, with mass defect in the form of release of high energy and some neutrons. Simple. I have made a different figure where there is a large nuclei is I said that converting into a smaller nuclei and the two smaller nuclei. Now we are going to see that actually what is happening. There is a uranium 235 and its atomic number is 92. So I am making you equation. If you remember this equation, just that is comfortable, no need to go for it. And I bombarded with a neutron. So upper one is considered an atomic mass, lower one is considered an atomic number. So here it is one neutron, its atomic mass is 1 and it is bombarded on, I said that uranium. So what is the total atomic mass? The total atomic mass 1 plus 235, that become 236. Yes, uranium 235, you should not say 92, you should say in the always with the name of atomic mass. Uranium, because it is changing. Isotopes are what? Their atomic number is always same, atomic mass is different. So when a neutron is bombarded on a uranium 235, it disintegrated into, दो नाम बताऊंगा, I will tell you, barium and krypton. Barium and krypton. Barium, it disintegrated into barium, and again I am telling you, it is not necessary that you should remember, but if you remember it will be good. Barium and krypton, and here it is, I have said that there is a 139, just 140, say 1 mass below, if you will see 139, and another it is, I said that it is 56 as an atomic number, 139 barium, and there is a 56, and another one it is in a krypton, just it is in the hundreds, 6 below 100, 6 below 100 is 94, it is 94, 6 below 100 is 94, and 36, 56, 36, that much. 140, 1 below 139, this is a it is in a barium atomic mass. Krypton, it is in a 100, say 6 below 94, clear, and here it is 56, 36. So if you are watching out that what is the atomic mass. So 139 and 94 became 139, and 139 plus 94 became 233. So there is a mass defect is 3. So there is a mass defect is, I said that what? Mass defect is, here you can say that mass defect is 3, and that mass defect has been converted into, I said that, energy. It is converted into energy. Always you remember that mass defect is converting into beta. I am writing, I am doing fission, barium and krypton, and here it is, we can be able to say like, and this mass defect, but at the same time how much mass defect? 3, and if you will add 56 and 36, it will become what? 92. So atomic number mein there will be not any issue, only there will be a mass will be reduced. So that mass has been, you can also write like this, 3, 1 neutron. So 3 neutron release, this mass defect, so that it is going to be balanced by the neutron release, and this is in the form of energy. 3 neutron released and energy. So this is the equation you can be able to see like, and it is in a nuclear fission. It is, I have written nuclear fission beta. Here it is nuclear fission and here it is nuclear fusions, and I am doing right now, and this nuclear fission will go, I said that I am doing all this, it is nuclear fission. And for the next, I will give the whole idea, even MTCR and all this, and the later on it will be coming for nuclear fission, because when you understand that, it is very easy to grab all this, it is very easy to So, you can see here it is nuclear fission, and nuclear fission, what we have been able to see that when a nuclear fission, what happened when a neutron is bombarded on a large unstable nucleus, then it disintegrated into two smaller nuclei with the mass defect, and this is the mass defect is releasing in the form of high energy and with some neutrons. And then how many neutrons? That is, I said that 139 and 94 become 233, and there is a 236. So 236 and 233, there is a 3 that has to be balanced by writing a neutron and 1, then in front of it multiply with the 3, that becomes 3 into 1 3. So, and that mass defect, it is energy and it is mega electron volt. So, nuclear fission, and then which are the, now the next, that perhaps it is all clear to all of you. So, the which are fissionable material, which are fissionable material, which materials are considered as a fissionable material. I said that only any nuclei which easily disintegrated by the bombardment of neutron disintegrated into smaller nuclei with the energy, it is known as fissionable material. Just I said that any large unstable nucleus after bombarding with neutron disintegrate into a smaller nuclei with release of high energy, then that material is known as, fissionable material. And which are fissionable material? So, which are fissionable material, that we can say like fissionable material if I am talking about fissionable materials are uranium 233, uranium 235, remember uranium 238 is not fissionable. Uranium 238, if you are bombarding neutron on the uranium 238, then it will not disintegrate, it means it is not a fissionable material. Uranium 233, uranium 235, thereafter I said that plutonium 239, and plutonium 241. These are the 4 material are fissionable. If you will bombard with neutron, automatically it will disintegrate into a smaller nuclei and releasing high energy. That is, I said that fissionable material. So, you must remember that uranium 233 and uranium 235 and plutonium 239 and plutonium 249, it is, I said that fissionable material. It is clear to you. But you know that we have uranium 238. We have uranium 238, and you can say like I said that I am not writing their atomic number because it is not necessary. Uranium 233 92, uranium 235 atomic number 92. It is not necessary to write atomic number, you can write without this also, and because we have remembered by the time, and there is a plutonium 239-94 and plutonium 241-94. So these are, I said that just remember uranium 233, uranium 235, plutonium 239 and I said plutonium 241. These are fissionable material which easily disintegrated into a smaller nuclei and releasing large energy. But there is a uranium 238 and another is a thorium 232. These are the two, they are fertile. They are fertile material. They are fertile material. Beta, we are not studying fusion, I am studying only nuclear fission. I said lots of time, I am studying right now only fission, F-I-S-S-I-O-N. I am studying fission means breaking, and I am here everywhere, the large nuclei is breaking into smaller nuclei. What does it mean? It is combining or breaking? If it is breaking, then it is, and I said that nuclear fission. Perhaps it is a general idea that you should have. I am always saying that it is in a fission, not saying fusion. Fission means breaking. In the initially I have a very small word, I said that what is the meaning of fission. I have written here it is breaking. And if I am breaking, then I am teaching what? Large nuclei is breaking and disintegrating into smaller nuclei, so it will never be a fusion, it will be, I said that fission. I'm everything, in every class I try to make you clear the concept and understanding the remembering it. So I will make the concept clear also. Right now I am saying that which minerals are fissionable. I am writing the name of it. The fissionable materials are what I said that uranium 233, uranium 235 and plutonium 239 and 241. And don't ask why. If you are neutron se bombard kar rahe ho, then it will be breaking, it is known as fissionable. That's the definition. Some student can ask, sir, why it is? We have tested with the several minerals and on their nuclei I have bombarded with the neutron. Those who are disintegrated, that is known as, those unstable are disintegrated, is known as fissionable. Those who are not able to disintegrate into smaller, they are not fissionable. Now the another point we are going to see, it is I said that fertile material, and fertile material I talked about, it is a uranium 238 and thorium 232. Just remember by heart also. I say so I said the fertile material are those material which can be converted into fissionable material. Fertile material are those material which can be converted into fissionable, and later on I can utilize in producing energy. So fertile material are those material which can be converted into fissionable material through some process. Yes, through some process. If something is converting into something, this is I said that known as what I said that means material, the process, that process it is, will talk about transmutation. That process to change one form to another, that you know that mutation, transmutation, that is a change in the what I said that character, the shape and all, its name has been changed. So I said that character and the shape, Fertile material are those material which can be converted into fissionable material, that is known as, and through some process, that is known as fertile material, and process is known as process is known as transmutation. Process is known as transmutation, means it is in a changing their shape and all, rupantran. So I said that it is in a transmutation, and which are the two fertile material, you must remember beta, uranium 238 and thorium 232. I said that listen here, if you know something, like I said that suppose I am talking about alpha decay, one word is beta decay, and one word you know that gamma decay. You must have heard about this. These are not too tough things in the class 9th and 10th. If you have studied and not studied, now you see that something is, if in my body, suppose there is a substance, sometimes in the movie you have seen that the radiations are coming out. So it is decaying out, energy is decaying out. Decaying out means of radiation is coming, the power is radiating out. Power is radiating out, and that energy and that substance energy is going to become less and less. Decaying out, decaying means somewhere decreasing, minus. So here it is, if it is alpha decay, you know that it is in the form of helium, जैसा बोला जाता, alpha decay will change atomic mass by 4 and atomic number by 2. In alpha decay, atomic mass will change by 4 and atomic number will change by 2. This is alpha decay. In case of beta decay, atomic mass will remain same, but atomic number will change by -1. So in case of beta decay, atomic mass will remain same, 0 and -1, that you can remember. Means atomic number will change by -1 and atomic mass will be remain same. This is clear, and gamma decay doesn't matter, it will remain the same. So I said that alpha decay, that perhaps it is clear. It is not too hard science, it is in a very simple science. I am talking about class 9th and 10th, and if you understand this one, you will start enjoying, and today you will go out of the class, when I leave the class you will enjoying, sir, oh so easy sir. Just follow the words and whatever I said, that 2 days after the class you will say that I understood sir, this is very much clear to you that what is nuclear technology. So I said that there is an alpha decay and there is an, I said that beta decay and gamma decay, means somewhere there is a change, decay means releasing out, energy is decaying out. So if I can be able to say like this one, suppose if I say there is an uranium 238 and its atomic number is 92, and what I did, beta decay. So what will happen, this is in a decay means minus, decreasing, yes or not, decay means minus. I have said that in beta decay there should be a change in the atomic number by -1. So here it is in the uranium 238, and it is a fertile. I have said that uranium 238, perhaps you just remember 238, thorium 232, uranium 238, uranium, thorium 232 are fertile, and thereafter I said that which are fissionable, which after the neutron bombarding easily disintegrated, uranium 233, uranium 235, uranium 233, uranium 235 they are fissionable, and plutonium 239, 241 they are, I said, fissionable. So after the fissionable there is a fertile, and this, what are the fertile material? Fertile समझते हैं ना, what is the meaning of fertility? Fertile needs some process. In the, if you are giving seeds into the, sowing seeds into the soil, then with the help of soil that it will start producing something. If you are taking seeds in your hand in the bag, it will not be productive. But if you are putting the seeds into the soil, then it will be productive. The same way there is some process to become fertile material, to become fissionable, that is transmutation. And here it is, I said that alpha decay, beta decay. Alpha decay mein mass will be changed by 4 and the atomic number will be changed by 2, and it is in the form of plus plus. But in case of beta decay, there will be atomic number, नीचे वाला atomic number होता है हमेशा, नीचे वाला atomic number होता है, ऊपर वाला atomic mass. Upper one is atomic mass, lower one is atomic number. Here in case of beta decay, that it is now atomic number will be changed by -1 and the mass will, atomic mass will remain same. So here we have uranium 238 and it is in a fertile. So I said that beta decay, and I did 2 times beta decay, means I said that 1 times beta decay, another again beta decay. So this -1 and this -1 and -1 finally gives, and there is a 238 plus 0 and 0, it become uranium. I said that it will be uranium 238, but here it is -1 that become what? +1, and here it is -1 that become +1. So finally it become 92 plus 1 that become 94. So 2 beta decay has changed the atomic number by 94, and I made an 1 neutron, and neutron means 1 upper mass 0, and that has been converted into, I said that plutonium 239 and 94. So you can be able to see that again I said that what I did, uranium 238 92 has gone for 2 times beta decay, 2 times beta decay, 2 times beta decay, and when it has gone 2 times beta decay, so what happened? It becomes uranium 238 and here it is 94 atomic number, and now I did 1 neutron to be added, it is converting into plutonium 239 and 94. So we have got the plutonium 239 94. Already you know that plutonium 239 and plutonium 241 is an what? Fissionable. So what happened? Uranium 238 has been converted into plutonium, uranium 238, which is in a fertile material, means if you bombard with that neutron it will not disintegrate. So what I did, हम लोगों ने, what we have done, 1 neutron and 2 beta decay has given us 1 neutron and 2 beta decay has given us plutonium 239 94, and it is converting into fissionable. So now fertile material converted into fissionable, and this process is known as a transmutation. This process is known as a transmutation. So transmutation. So the uranium 238 is what I said, that fertile, converting into plutonium 239. In similarly another, what is the next fertile? Thorium 232, perhaps you remember. This is uranium 238 is a fertile. It is not used for producing energy because it will not disintegrate. So we have converted into fissionable plutonium 239 with the 2 beta decay and 1 neutron. Similarly, thorium 238 will be also converted into, I said that fissionable. So this is the one I said that another it is in a thorium 232 and atomic number 90 with the help of in the similar process one neutron and 2 beta decay, 1 neutron and 2 beta decay converted into uranium 233 92. So uranium 230, the thorium is converting into, thorium 232 is converting into uranium 233. And if I can show you like this, perhaps you can see like here, I have a thorium 232 90. So first I did what? Beta decay 0 minus 1, then again decay means minus, beta 0 minus 1. So this minus 1 and minus 1, this minus 1 and minus 1 become plus 1. So here it is plus 1, this is what I said, that plus 1. Here it gives thorium 232 and 90 plus 1 92, and this and there is a 0 0, 232 plus 0 232, it remain. Then I did what? 1 neutron. I said that 1 neutron, and it is, I said 1 and 0, and that become uranium 233 and 92. Clear? So this way we have been able to see this is a transmutation. And if you are knowing that, then you can understand the whole process of, I can make you everything so easy, but to keep on flow along with me, and if I say something, then at that time you just keep on saying. So which are, I said that which are the two fertile materials are uranium 238 and another is 232. It is clear. These are the two fertile material, and it is converting into plutonium. Uranium 238 is converting into, just याद कर जाओ बेटा, next classes जैसे जैसे हम लोग will keep on moving, you will say that so easy sir. Plutonium 239 plus minus, so you should understand that, I can't make you to understand, it is an easy process, and thorium is converting into uranium 233. So that's an easy process you can be able to say. Perhaps now it is very much clear which are fertile material and which are fissionable material, and fertile material has the capability to convert into fissionable material. So here it is, I said that which are fissionable material, and another it is a fertile material. And fissionable material, the material those who after the neutron bombardment, it is easily disintegrated into smaller nuclei. And these you know that it is uranium 233, uranium 235, plutonium 239 and plutonium 241. These are, I said that fissionable, and the fertile material which are not disintegrating into smaller nuclei after the bombardment, these are fertile, but they can be converted into fissionable through the process of transmutation. It is known as, like I said that uranium 238 and another it is, I said it is thorium 232. They can be converted into uranium 233, and uranium 238 will convert into plutonium 239. So here it is, you should understand. Now I am going to give one question so that नहीं बेटा, वो थोड़ा सा मैंने केवल आपको समझने के लिए लिखा है. ये जो समझने के लिए लिखा है, एक्चुअली इट इज इफ द 92, ये न्यूट्रॉन वाला पहला लिखना है हमें, ये आपको रिएक्शन लिखना नहीं है. दिस रिएक्शन इज नॉट इन द यूज. जनरली न्यूट्रॉन को पहले करते हैं, फिर उसके बाद हम लोग क्या करते हैं, न्यूट्रॉन से पहले डालते हैं, फिर 2 बीटा डीके करते हैं. It is initially we do neutron, and then when I am changing nitrogen, then it is automatically becoming uranium. Atomic number change it should be, but it is not in concern. This reaction does not, only your comfortability I am writing this reaction. I am writing this reaction, otherwise यहाँ पे मुझे क्या लिखना चाहिए था, uranium 232, because 92 if I am writing, atomic number change, it means I said that the element has been changed. It is okay, just making to remember that okay, thorium 232 is converting into uranium 233. Its a reaction should be what I said, that one neutron first, and I am making it because the most of the time when I am teaching the students getting problem in the beta decay, alpha decay, what is this, therefore I have written it for the first. Simply therefore हमने at the end only what it is important, this one is important, thorium 238, 1 neutron and 2 beta decay, therefore here it is I am written 1 neutron in the initially and 2 beta decay converting into uranium 233, and here it is uranium 238 is converting into plutonium 239 and with 1 neutron and 2 beta decay. Now my question is, I said that one question that which of the statements are correct, which of the statements are correct regarding nuclear fission. First statement, and neutron bombardment, first statement, neutron bombardment, on large and stable nuclei, large and stable nucleus disintegrate into two smaller nuclei with mass defect in the form of release of high energy and neutrons. Second statement, in mass defect is the real cause of release of energy. Statement third, uranium 233 and uranium 235 are fissionable and uranium 238 is fertile. Fourth, nuclear energy released nuclear energy measured in mega electron volt, Again I am repeating these questions. Which of the following statements are correct regarding nuclear fission? Neutron bombarded, first statement I said that neutron bombardment on large and stable nucleus disintegrate into two smaller nuclei with mass defect in the form of release of high energy and neutrons. Second statement, mass defect is the real cause of release of energy. Second statement, mass defect is the real cause of release of energy. Third statement, uranium 233 and uranium 235 are fissionable and uranium 238 is fertile. Third statement, clear. And the fourth statement, released nuclear energy measured in mega electron volt. Which of the statements are correct? Read the statement properly and carefully. Read the statement carefully. If we have given the class and if you have understood the class very carefully, and at the same time if you have, I said that, gone through the statement very carefully, then you can easily, I said that, find out which statements are correct and which statements are wrong. Be careful in giving answer, beta. Be careful. Be careful in giving answer. I am just reading the first statement. Neutron bombardment on large and stable nucleus disintegrate into two smaller nuclei with mass defect in the form of release of high energy and neutrons. And second statement is talking about mass defect is the real cause of release of energy. And then third statement, uranium 233 and uranium 235 are fissionable and uranium 238 is fertile. Everybody involve yourself, don't consider. And here only I have done a minute change in the statement that has made the statement to be correct, or generally UPSC is understanding that what the student can make mistake, because one, during the prelims examination or any examination you have one psychological pressure, and if you are prepared then you have a psychological pressure. If you are little bit less prepared you have a more psychological pressure. These are the two guys are there. One who is not prepared, they do not have psychological pressure, and who is, I said that, highly prepared, those do not have, those student does not have psychological pressure. But the middle section has always psychological pressure. Yes beta, that's good. The point here it is there, I made a change. The point here I have made a change. This is watch it out. If I have started the first statement when I have given that the radioactive mineral or any nucleus that has to be disintegrated, they should be unstable. That should be unstable, and if it is unstable then it will disintegrate. If it is unstable then it will disintegrate. Clear? If it is stable it will not disintegrate. Remember that if a nucleus is stable, then why he will disintegrate? Which kind of element will disintegrate. So the problem here it is the some student is making, here it is in a stable, this is, it should be, what is the correct statement here? Should be unstable, it should be. So the first statement is wrong. Second, mass defect is the real cause of release of energy, that is correct. Uranium 233 and uranium 235 are fissionable and uranium 230 is fertile, that is correct, and released nuclear energy measured in mega electron volt. So that is, I said that here you can be able to say, so the second and third and the fourth statements are correct, and most of the students, those who have I said that given their answer, only I said this is the one here you can be making a mistake. So please, again I am telling you, this exam is not about the knowledge, but at the same time, though it is the exam where the student is having very humble and very, I said that humble in approach in the society. If you are very humble in the approach in the society, automatically you will, your approach for any kind of action if you are taking, it will be humble. You will not panic. Sometimes you panic and you make a mistake which you know, and that is not known as a mistake, it is known as blunder. Blunder means biggest mistake, and some of you, only I have seen that that 3-4 student has made such mistakes, and this mistake is, I said that do not panic, better, do not be in hurry, read the statement properly, whatever you have done. So here it is, the first statement is wrong. Clear to all of you? And the next one more question I am giving. Which of the, so its answer is, I have said beta, sometimes students are asking sir which is, so answer is which one? 2, 3 and 4. 2, 3 and 4 are correct. Now the next question, if I am saying that which of the statement is correct regarding transmutation? First statement, बेटा मास डिफेक्ट मैंने शुरू में ही पढ़ाया कि मास डिफेक्ट क्या है. आपने स्टार्टिंग की क्लास ध्यान से नहीं सुने क्या? Shamir, I have said that mass defect means, I said that here I have said if there is a large nuclei having 10 as a mass, large nuclei having 10 as a mass, 10 as a mass, and it has been disintegrated into 2 nuclei with the 5 and 4. So here it is 10 and here it is total 9. So there is a loss of mass by 1. One mass has been defect. So this mass defect will be converting into energy. This mass defect is converting, here it is again, I said that this is the 10 mass and here it is, I said that 5 mass and here it is, and I said that 4 mass. So whatever the mass is, I said that changing, and then there is a change in the mass, there is a 1 mass change, 2 mass change, 3, whatever it is the change, that will be utilized for energy. And energy, I have said that it is E equals to mc square, and E, and put the mass and the speed of light c square, and that much of energy will be released. It is very high amount of energy released by the nuclear fission, and that you can say that it is nuclear fission. It is clear to all of you? Better be on time, okay? In my class, I said that I am building one concept over another. So every concept, if I am giving, it will be based on the earlier concept. It is over the another. So be on time instead of joining late, okay? So I said mass defect is converting into energy. If it will be in my class, every concept will be utilized in, I said that, understanding the full topic. I never say any student to come in my second class, because it is based on the earlier class. So please be on time. So here it is, second question, if I am talking about which of the statement is correct regarding transmutation. Transmutation, I said that first statement, it is, I said, it is change in the character of atoms. It is change in the character of atoms. Transmutation, here the question is, transmutation regarding nuclear fission. It is a change in the character of atoms. Second, be careful, I have made you to understand, accordingly you have to answer. Second statement I am saying, in here fertile material convert into fissionable material. Third statement, uranium-238 is fertile material through transmutation converting into plutonium-239. So here I have given which of the statement is correct regarding transmutation, which of the statement is correct regarding transmutation of nuclear fission. So the first, it is a change in the character of atoms. Second, here fertile material convert into fissionable material. Third statement, uranium-238 is fertile material through transmutation converting into plutonium-239 as fissionable material. Which of the statements are correct regarding transmutation? I said that which of the statement is correct regarding transmutation of nuclear fission. First, it is a change in the character of atoms. Second, I said that here fertile material convert into fissionable material. Third statement, uranium-238 is fertile material through transmutation converting into plutonium-239 on fissionable material. बेटा जस्ट आई एम मेकिंग, आई सेड दैट म्यूटेशन का मतलब होता है चेंज, अंडरस्टैंड दैट, ट्रांसम्यूटेशन चेंज, mutation means, I said that change, mutation means, I said mutation means what? Change. You should see what I am saying, you should see behind also, you should also see at the back of it. Students generally make mistakes also when sometimes what happen, they understand that okay I know, and in the hurry they make mistakes. बेटा फिलहाल क्वेश्चन करो, you can see the videos. My question is, which of the statement is correct regarding transmutation of nuclear fission? First statement, it is a change in the character of atoms. Second statement, here fertile material convert into fissionable material. Third statement, uranium-238 is fertile material. Uranium-238 is fertile material, and through transmutation converting into plutonium-239 as fissionable material. Yes beta, in this one I have said that mutation, if you have transmutation means one atom to another, if it is converting into from uranium-238 to plutonium, it is a changing in the character. It is a change in character beta. Hidden means what? If it is a carbon is converting into oxygen, means I said that it is a change in the character, and uranium is converting into uranium-238 is converting into plutonium-239, it simply means it is a change in the character. You should be say that, I will suggest all of you, you say either yes or no, don't be in between. Perhaps, you stop saying the word perhaps, because in the examination hall you should not be in the line of perhaps. When you are in the perhaps, several question you can make, some question there will be a chance of making a wrong. So be either yes or no, because you understand transmutation, plutonium, uranium-230 is converting into plutonium-239, thorium-232 is, then I said that fertile material and converting into uranium-233. So it is a change in the character, so the first statement is correct, and here fertile material converting into fissionable, so second is also correct, and third uranium-238 is in a fertile material and through transmutation converting into plutonium, third is also correct. It means all are correct. So understand that how do the UPSC. Perhaps if you are understanding that this is not any easy question beta, go and ask those who have done something, prepared for civil services or something, and if you will ask, give them chance, one day read and come to me, one day read nuclear technology and come to me, because generally they never teach basics, where if you are not knowing basics you can never understand why do the energy is produced due to the nuclear fission, because the mass defect is really responsible for it. And if you show this question to the other student, those who have prepared for since some days, there is a high chance some student can do the correct, but there will be high chance that they will make mistakes, because the basics are not clear. So for clearing the basics, be present in the class. When I will start the class, at the time you should be there with me. Uranium-238 is a fertile material beta, अभी मैंने पढ़ाया था, and plutonium-239 as an fissionable. Third is correct beta, third is correct. I have told you, here it is. Here it is, uranium-238 is converting into plutonium-239. Uranium-238 is converting into plutonium-239. Clear? So now my question is, next one, it is thermal neutron. What is I said that suppose here it is uranium 235 92. and if I bombard with neutron, then it should convert into barium and krypton. Yes or not? Barium and krypton. So it should convert into barium and krypton. When I am bombarding, then it should convert into barium krypton with a large, and then there is an, I said that 3 neutron, and I said that energy in the form of mega electron volt. Clear? When the neutron I am bombarding, अभी तक तो till now I am talking about only neutron bombardment, and but now I am going to talk about thermal neutron. I am making in 2 pictures. Here it is. Listen me. Here it is uranium 235. Here it is uranium 235. Here I bombarded with neutron, and the neutron passed through it. Because its speed is passed through it, because its speed is fast. Listen me carefully. I said that if if uranium will be there, there is some condition that uranium has to be, suppose I am an uranium 235, and neutron is coming towards me, and then if my body, if I am uranium 235, if my body is not able to absorb this uranium 235, then it will pass through this. So there will be no, I said, disintegration. For disintegration, bombardment means it should be absorbed by it and then disintegrate. And therefore what I'll do, because here the neutron is, what I said that, fast. But I did what I said that neutron speed is, I said that I made it slow. Simply जब भी neutron आएगा, whenever the neutron will come, it will be fast. Normally neutron is fast. Normally neutron is fast. But I have to make it slow. So that it is absorbed. When it is absorbed, then it will disintegrate into barium, krypton, 3 neutron, and a large amount of energy. So the slow moving neutron is known as thermal neutron. Slow moving neutron is known as thermal neutron. And who makes it slow? I said that one, it is moderator. So in our nuclear reactor, when it is, I said that nuclear, where the electricity is being produced, where we are producing electricity, in that one I will put some moderator, and moderator will do, when the neutron is coming, then their speed will decrease, and when the speed decreases, then it is easily able to absorb by the uranium 235, and uranium 235 fission, broken, disintegrated. So here the most important part is neutron or thermal neutron. Thermal neutron means a neutron who is moving slowly with the help of moderator. So what is the job of moderator? Perhaps you understand. What is the job of I said that moderator? Moderator job is what I said that slow the speed of neutron, and it means, next point, it is converting neutron into thermal neutron. Thermal neutron. Yes. Fertile material convert into fissionable, that process is known as transmutation, beta. Now I am coming on to the next, please understand it. You just switch over here to this side. Just switch yourself here. Moderator. Moderator का job क्या होता है? What is the use of moderator? What is the job of moderator? Everyone reply, then I'll make it very easy for you. And then today, after the, just when the class will finish, you can understand how do the nuclear reactors are working. You can understand how the nuclear reactors are working, and it's an, I am giving you guarantee that at the end of the class 80% will be clear to you. Some student 100% clear, but 80% I'll tell you, all of you clear if you are watching me and listening me very carefully. I said that बेटा थर्मल न्यूट्रॉन जब हमारे बॉडी में कोई चीज एब्जॉर्ब नहीं होगा, बहुत फास्ट मूव कराएंगे. सपोज करो कि मैंने तुम्हारे मुंह में खाने के लिए मुझे कुछ फेंकना है. इफ आई हैव टू थ्रो समथिंग इन योर माउथ, ओके, एंड इफ आई थ्रो समथिंग वेरी फास्ट, देन योर इट विल कम इन योर माउथ एंड इट विल गो अवे. इफ इट इज पास थ्रू दिस, इफ इट इज नॉट एब्जॉर्ब बाय योर बॉडी, देन देयर विल बी नो चेंज इन योर बॉडी. यस और नॉट? I said that fissionable बनाने के लिए भी क्या होना चाहिए? That fissionable means neutron should not come fast. If the neutron is coming fast, then it is easily pass through this. Easily pass through this, and there will be no fission. So for fission, neutron speed should be less, and that neutron is known as thermal neutron. That neutron is known as thermal neutron. That neutron is known as thermal neutron. My question is now, what is the job of moderator? Tell me. What is the job of moderator? Just if you understand, then answer me. What is the job? And if you speak out, then you can understand. And I'll show you the animation, how do the nuclear reactors are working. What is the job of moderator? Tell me fast. Everyone please. What is the job of moderator? What is the job of moderator in nuclear reactor or anywhere? Moderator, M-O-D-E-R-A, moderator, M-O-D-E-R-A-T-O-R. Moderator word, if you have heard about, before this class itself, moderator matlab become moderator. If you have heard about, sometimes you are highly excited, sometimes you are, I said that, moderate. Extremist in the history, if you have heard about extremists and moderates. Everyone please answer fast. What is the role of moderator? What is the role of moderator? All of you are correct, beta. All of you are correct. Now my question is, my next question to all of you. Listen me carefully. I said that my next question to all of you. My next question to all of you. If we are moving in air, in the atmosphere right now. Around us, what is there? Air around. Around us, what is there? Tell me, around us, what is there? Air. So, if I am moving in air, and thereafter I started moving in water. If I will move in water, my speed will be slow or fast. If I will move in water, my speed will be slow or fast. If I move in water, my speed will be slow or fast compared to air. Means if I am running on the road in the air, if I am running on the road in air, my speed will be something, suppose 20 km per hour. But if I will move in water, my speed will be slow or fast relatively. My speed will be slow or fast. Very good all of you, very good all of you. So, you are reaching near answer. Yes, somebody is obstructing, yes or not? So, moderator in nuclear reactor means nuclear plant where the electricity is producing. Nuclear reactor is, who is moderator? Water. Water will reduce the speed of fast moving neutron. Second, it is heavy water. What I said that? Heavy water, heavy water. Then I talk about, listen me carefully, water, heavy water, and then I said that graphite. In our nuclear power plant, these are the three things are utilized for reducing the speed of neutron. Reducing the speed of neutron means converting into thermal neutron, and these are water, heavy water and graphite. It is clear? So, perhaps through some kind of, I said that entertainment approach, you understand then which are moderator. In our nuclear power plant, moderators are water, heavy water, heavy water and graphite. Clear? Clear? So, I said that moderator, thereafter I am talking about coolant. Another word that I am going to utilize, coolant. Coolant. Suppose I said, if we have a car, generally if you are giving your car for the service and any vehicle, generally we used to put coolant so that machine can be, instead of warming, it should, what I said, that become cooler. So, what is the job of coolant? To absorb the extra heat, absorb the heat, absorb the coolant का job क्या होता है? If you have heard about absorb heat, absorb heat. Coolant means, if you have heard in the, I said if you have heard in your, I said car, any kind of vehicle, there is we used to put some coolant. So, when the car or any vehicle get extra heated, then those heat is being absorbed so that the engine should not become highly heated. The job of coolant is to absorb heat. Absorb heat. The second one I talked about, first I talked about moderator. What is the job of moderator? Slow down the speed of neutron. Or better to say, making thermal neutron. And these are, I said that these are, I have said, which are clear. Next point, if I am talking about coolant means absorb heat. If I am giving heat, then the water will be there and it will absorb heat. Let us go into thermal power plant. Let us go into thermal power plant. Thermal power plant. What happened? I said that there is a water. I said I am giving heat, and here we have, I said that water. I am giving heat, then this heat is absorbed by water, then the water is acting as what? If I am giving heat, then water is absorbing the heat, then the water become what? Coolant. Water, or it can be or any liquid, I said that water became coolant, and after that water will convert into steam, and this steam will move through this. This steam is moving, and when it is moving through this pipe, then there is a turbine. Turbine means fan. There will be a fan. There will be a fan. Then this steam will put the pressure on the turbine, and then turbine started running, turbine started moving, and when the turbine, jo pankha hai, that fan started moving, and due to this movement there will be an one generator, and generator started moving, and then electricity produced. Electricity produced. I said that who is coolant here? Water. Water converted into what? If you are giving heat, the water is able to absorb the heat. It is able to absorb the heat, and by absorbing the heat, it converted into steam, and thereafter steam is putting pressure. Steam, जानते हो, it is a very dangerous, very fast moving steam, and it is able to turn the turbine, and turbine is started. If the turbine is moving, then there is a generator. Generally, if you have seen generator, nahi bhi dekhe hoge, doesn't matter, then generator started moving also, and there is an electricity production. Simple, turbine, generator. So this is the thermal power plant works. The similarly nuclear power plant also works. Listen me. So the who is coolant here? Water. So means coolant means absorption of heat. What is the meaning of coolant? Absorb heat. And who will be coolant? Who will be coolant? The coolant can be what I said that, tell me, water, heavy water, they are also coolant. They are moderator also, they are coolant also. Thereafter some gases. Gas can also absorb the heat and it can move, and it is in a liquid sodium metal. Just remember, liquid sodium metal. So which are coolant who can absorb the heat from the nuclear reactor? In the nuclear energy, you know that in the nuclear power plant there is a high amount of energy is producing, and that energy to be, what I said, that absorbed by, that energy or heat to be absorbed by either water or heavy water or gases or liquid metal. So perhaps these two things are clear to all of you. These two things are clear to all of you. My next point that you should try to speak with me. These 6 words you have to speak with me, then I will come on to moderator, control rods. Speak with me. Moderator, control rod, shielding, moderator, control rod, shielding, coolant. Which are we have said? I said that moderator, just remember by heart, moderator, control rod, shielding, coolant. Do not understand that what it is. Abhi just in the next 15-20 minutes you will be the perfect in the nuclear power plant how it is working. Moderator, control rods, shielding, and then I said that coolant. Clear? Thereafter I said that turbine, generator, turbine and generator. Abhi humne, I have discussed with you this moderator, I have discussed with you moderator, I have discussed with you coolant, turbine, generator. What is the job of moderator? Moderator, I have said that it is, and I said who reduces the speed of neutron like water, heavy water, graphite. Then I said what is the job of coolant? Coolant who absorb heat, like water, heavy water, some gases and liquid sodium metal. Then I said what is the turbine? Turbine is the one who convert steam energy into mechanical energy. Steam energy, steam is coming, heat energy, और heat energy से क्या होने लगा? It started moving. तो turbine का job क्या है? What is the job of moderator? Job is, I said that slow down neutron. Coolant job is, I said that absorb heat and convert into steam like this. Turbine job is convert heat energy into mechanical energy. Mechanical means पंखा घूमने लगा, something is moving, tire is moving, wheel is moving, anything is moving, you started running, anything is moving, mechanical. So mechanical energy, heat energy is what is the job of turbine? Turbine means steam is coming and the turbine started moving, heat energy into mechanical. And generator क्या करता है? That mechanical, जब in the generator something started moving, then what happened? Mechanical energy घूमने की वजह से electricity production. So due to the movement in the generator, electricity produced, means convert mechanical energy into electrical energy. So these are the things that you have seen perhaps. I said mechanical energy into electrical energy. What are the four things I have talked about? Perhaps it is clear to all of you. Moderator, control rods, I talked to you what? I said what are the four things I have talked about? Tell me what are the six things जो आप जानते पहले बताएं. Moderator, coolant, then I said that yes, turbine, then I said that generator. A part of it we have seen shielding, and another one we have seen, I said that there is control rods. Try to remember those 6 names in your mind. I will come on to these 6 names, and thereafter in the next few minutes it will be, I said that you will be the perfect. Another I said, my question is here, I am going back to the nuclear fission again. Controlled suppose there is a chamber, suppose there is a chamber and there is an uranium is there, uranium is there, uranium rod, uranium fuel, uranium 235 suppose, clear, and it is always in the form of pipe. Uranium we put into a particular pipe, so it is known as uranium rod, and it is, and I said that this outer cover is known as shielding. जो आपने बना हुआ घर देखते होंगे, the structure it is made of concrete, it is known as shield, जिसका जॉब होता है कि अल्फा गामा बीटा एनी काइंड ऑफ रेज विच आर कमिंग थ्रू द न्यूक्लियर फ्यूजन इट शुड नॉट कम आउट. Shielding very easy, shield. So one I am talking about controlled nuclear fission, and in the similar way another chamber I made, and in the chamber we have nuclear rods, nuclear fuel, uranium, clear. There is this is your shielding. Now, and here I will talk about uncontrolled fission reaction. Uncontrolled, the two types of fission reaction, one it is controlled, and here I said that here I said that here we have some controlled rods. Here I have some controlled rods. So this is, I said that this one is, I said that uranium fuel, and these are control rods. What happen when one neutron is bombarded on, uranium 235, so it break into barium, krypton and 3 neutron, clear? And you can understand that there will be not one neutron, there will be lakhs of neutron, it will be bombarded. In the nuclear power plant, there will be, I said that several neutrons will be bombarded. Several neutron will be bombarded. Lakhs of neutrons has been bombarded, and you can be able to see, like I said, this 3 neutron will, I said that, will bombard with uranium 235, यहाँ से जो रिलीज हुआ, there are the 3 neutrons, and these 3 neutrons will again convert uranium into barium, krypton and again 3 neutron. All will release 3 neutron. Means in one chain reaction, in one reaction we are getting 3 neutron, so and at the end we are getting 3 neutrons. One neutron, So these 3 neutron will bombard with the another 3 uranium. You can see, like I said, here it is neutron on the uranium, and we are getting barium plus krypton and then 3 neutron. 3 neutron means neutron, and they will also means they will strike with the uranium, and uranium will convert into further again barium and krypton, and there is a 3 neutron. 3 neutron means neutron, 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 and this neutron will also uranium, barium, krypton and 3 neutron. So here it is, I said that neutron, 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 so these 3, and then this neutron is also converting into 3 neutron. And thereafter means 1 neutron is converting in giving 3 neutron, and 3 neutron is giving 9 neutron will, and they will also strike with the uranium 3, 3, 3, 3, every one 3, 3, this time it will become 27. So it will become 1, 27, 1, 9, 27, 81, 243, then 729, like this it will go infinite number of neutrons, thousands and lakhs of neutrons. And it is looking like chain reaction. It is looking like chain reaction means 1 neutron is giving 3, 3, 3 will give 3, 3, then 9, 9 will give 3, 3, 3, 27, then 27 will, the 27 neutron will give 3, 3, 3 neutron after the bombardment. So there will be a non-stoppable reaction, it is known as chain reaction. And when there is this kind of reaction, this is known as uncontrolled. When there is a neutron, when the neutron is not controlled, when a neutron is not controlled, it is known as chain reaction and non-stoppable and non-stoppable, and this is known as atomic bomb. And जब हम लोग एक बार एटम बॉम्ब छोड़ देते हैं, उसमें यूरेनियम होता है, तो there is, I said that we do not control the neutron, and when we are not controlling the neutron, then the neutron keep on striking, 3 converting into 9, 9, 27 lakh is converting into 3 lakh, 3 lakh is converting into 9 lakh, 27 lakh, like this. And then reaction keep on happening, and largest amount of energy, like in the Nagasaki and Hiroshima, when there is a nuclear uranium has been or plutonium has been left over, then there is an uncontrolled, and that is known as atomic bomb. Means it is not, एक बार हमने छोड़ दिया uranium and neutron is keep on striking and releasing, it is not in our hand, it is known as uncontrolled nuclear fission. Fusion नहीं, fission, it means atomic bomb. But we have a controlled rod. हमारे पास क्या है? There is a controlled rod, and then controlled rod क्या करता है? It absorbs neutron. I said that what is the control rod? Control rod means absorbing the number of neutrons. Suppose करो, I said that आपने, so in the nuclear reactor plant there is I said that control rods will be there. If we are putting little bit control rod inside, so there is a neutron and the 3 neutron released, means I said that neutron, 3 neutron. So if I put little bit control rod, then out of that 1 neutron is, I said that, absorbed. Then how much left to react? We have left to react this one. But if I put more inside control rod, then I said that 2 will be absorbed. And if I put the control rod fully inside I said that chamber, then all neutron will be absorbed and nuclear power plant will stop. यदि मुझे न्यूक्लियर पावर प्लांट स्टॉप करना है तो आई विल पुट द कंट्रोल रॉड. व्हाट इज द जॉब ऑफ कंट्रोल रॉड? इट इज, आई सेड दैट, absorbing the neutron. Absorbing the neutron. So in the nuclear reactor, if I have a Rawat Bhatta atomic power station, if I have a Kakrapara, Tarapur, Kaiga, there are several atomic power plant in India. So there in that one, there will be a control rod will be there, those who are controlling the nuclear fission, means absorbing the neutron, and it will be under the control of us. यदि मुझे चाहिए, if I need that only one neutron will go, so I'll put the control rod more, 2 neutrons will be absorbed. If I need little bit, now 2 neutron has to go, then I'll say that only little bit, I'll put little bit control rod inside the chamber. Listen me carefully. If I'll put little bit inside the chamber, 1 neutron out of 3, 1 neutron absorbed. If I'll put more, 2 neutron absorbed out of 3, 1 neutron is doing reaction. If I'll put fully, nuclear power plant stop. यदि मुझे nuclear power plant stop करना है, if I have to close the nuclear power plant or stop it, then I'll put the control rod fully inside and there will be no neutron, all neutron absorbed, so there will be no nuclear fission. So what is the job of control rod? Control rod is, I said that, controlling the number of neutrons, means I said, if I am not controlling, it is an, I said, if I am not controlling, then the neutron is keep on doing chain reaction and it is unstoppable and it is known as atomic bomb. यदि आपसे पूछे atomic bomb is a nuclear fission, you will say yes, but it is a controlled fission reaction or uncontrolled, then you will have to say it is uncontrolled. But when somebody asked in the क्या nuclear power plant or nuclear reactor is a nuclear fission, you will say yes, but here it is controlled or uncontrolled, then you will say that it is a controlled. If it is uncontrolled, then the nuclear power plant can blast. So I have to utilize control rod to control the chain reaction or control the number of neutrons. Perhaps it is clear. That control rod means controlling the neutron. So my question is, now there is what I said, that controlled fission reaction, better to say controlled nuclear fission, and another it is uncontrolled fission, nuclear fission, uncontrolled nuclear fission. Uncontrolled is there is no control rod and it is what is happening, atomic bomb. So whatever the atomic bomb, nuclear bomb somebody is talking about, there will be no control, uncontrolled. But if I am controlling it, then I can control, and that energy is in our control to produce. If I have to produce more energy, then I will produce more neutron. Then I said that control rod out. And if I have to control the production of energy more, then I will put the control rod inside and the less neutron will release and the less reaction, the less energy. So control rod is utilized in nuclear reactor, and it means nuclear power plant. It is clear, nuclear reactor means nuclear power plant. So perhaps it is clear to you, that my question is, now listen me carefully, and I am going to show you one, listen me, this is